Thank you very much. It's good to be in Russia for the first time and giving a presentation at this excellent conference. So yeah, I'm James. I'm going to be talking about UAC, ways to bypass it, some interesting ways of bypassing it, and also some sort of funky behavior in Windows which you can abuse to gain privileges. Now, what I'm really going to be talking about is basically how UAC is actually probably worse than most people realize. Like, everyone knows you can bypass UAC on Windows. You can get rid of the prompts, you can get admin privileges if the person is logged in effectively as an administrator. But it turns out that not only was it bad, it was very, very bad. So let me just at least start with a bit of an architectural overview of UAC before we go any further, because it will Windows. So this is Vista and above. If you have enabled UAC on Windows, what the operating system actually does is it creates two so-called logon sessions. Now, the first logon session is your normal administrative user. This is your elevated logon session. But Windows also then creates a second logon session, which it's the limited user. So this is the one which you actually log in as. When you start up your logon session, you get access to basically an unprivileged user. And in theory, these two logon sessions are separate, but the main thing is they all sort of exist as that same user. So you then need some sort of escape hatch, some mechanism to go from your low privilege user to your high privilege user. And the way that actually works is usually an application will say, use shell execute, an API in Windows, and it will use the run as verb, which says, I want to run this as an administrator, please. And under the hood, shell execute actually calls something called the app info service. And this is a system service which is responsible for implementing UAC. I don't actually know why it's called app info rather than, say, user account control service, but that's just the way Microsoft named it when they originally built it. Now, as part of RPC service, it verifies the information coming from the low privilege user, and it pops up the now familiar UAC dialog. The usually click yes to get owned, click no to maybe you will still get owned, but not this time, mate. If you click yes, then that UAC prompt will go away. The app info service now gets a, yep, cool, that person is elevated, and it will actually spawn your privileged application at that point, using whatever criteria the limited application gave. So, in theory, you can't bridge this gap without getting the app info service involved. And the reason you can't bridge that gap is something called linked tokens. So when you've got your limited token, your non-administrative token, in fact, under the hood, that is linked inherently to your elevated session, your elevated token. So in this particular case, we've got just a sort of basic information about your token. So this is your limited token. And you have things like your user SID in there, which is your user identity. But your linked token, then, while it still maintains your same user identity, it has something called an authentication ID, which is your logon session ID, which I showed in the previous diagram. And those differ between your limited session and your elevated session. There's a few other differences. For example, something called integrity level, which will be important later on, goes from a level of medium, whatever that really means, up to high. And you can kind of sound, they're just comparative levels at that point. And then there's also, right at the bottom, it sort of indicates that this token is elevated or not elevated, as the case may be. And this sort of is an indication of whether this token has admin privileges or not. But it's not just those small changes. There's a number of other differences between the two tokens. One of them is in your group. So obviously an administrative token has the administrators group, because a lot of the access control entries for Windows will say, I grant any administrator on this system to access that resource. So obviously we need to remove those. So the limited token effectively removes these groups from the list. Now they're still there. You can kind of see them. They look sort of orange in this display. These are because these are actually deny-only groups, and deny-only groups are just there to determine if someone isn't allowed to access a resource, but doesn't grant you access to that resource. But effectively, all that means is you no longer have the admin group, which kind of makes sense. And the other major difference is you lose privileges. So privileges are like short-circuiting for the Windows security model. So for example, you've got a privilege to change the time zone. Now rather than determining who by user identity is allowed to change the time zone, there's just sort of a bit flag which says this person has the ability to change the time zone, and it will just do a check, simple bit check. Yes, it does have that job done. But there's loads of dangerous privileges which really, really should not be granted to low privileged users. And we'll see some of those in a little bit. But basically, you can see on the left that there's pretty much no privileges. There's 5 different privileges, and none of them are particularly dangerous, whereas the admin token has loads more, which all do nasty things. So the problem with UAC, and why Microsoft effectively do not consider UAC a security boundary, is because both that non-admin session and the admin session all share the same resources. They share the user profile because they're still the same user, so their profile on disk has to be the same. They share the same registry hive, so each user has their own registry hive, and they're shared as well. Finally, there's desktop and kernel objects, and this is where I'm going to concentrate the rest of this presentation. A lot of the other attacks, so things like user profile and user registry hive, they're sort of your classic UAC bypass attacks, whereas desktop and kernel objects are a bit more specialized. So that's where we'll focus. And the thing we'll focus on specifically is something called the logon SID. Now, in order to support sharing of kernel objects, the OS needs to basically grant both the low privilege user and the high privilege user access to the same objects, effectively. And it can't easily do it by user group because of strange behaviors in the security model. But what it can do is it can give you, when it creates your token, a new SID. And this SID is shared by all users running on the same desktop. And that obviously means both the non-elevated and the elevated user both have this SID. But crucially, when you look at a number of kernel resources, in their access control entries, in their security descriptor, you see this logon SID as well, granting that user access to that resource. So in this particular case, we've got an access token, access control list, and we see the logon SID there, which effectively gives almost complete access to that token. So this sort of is an interesting behavior, like the fact that you can share kernel resources between 2 different sessions. And one of the first things I found was in Windows 8.1, Microsoft introduced a new Win32k system call because, as everyone knows, Win32k is the most secure component on Windows, and they had to add more functionality to it, which made it even weirder, right? But what this function did, this system call did, was whenever a process on the desktop writes something to the clipboard, so just writes a text string to the clipboard, say, it will create a reference to the effective token which was active at the time of that clipboard write. So take, for example, an admin process. If an admin process writes to the clipboard, then Win32k will capture a reference to that token, and so a reference to the admin token. But then there's a system call, this NT user get clipboard token. And what that allows you to do is, as a non-administrator user, you can query a reference to that captured token. And it just so turns out, because of the way the access control list is secured, and you've got this logon SID, you get read access to this access token. So effectively, you've now got a handle to the admin access token, which in theory shouldn't be easily possible to do. But so what? So what can you possibly do with that access token? Well, you've got a number of possible options. You can, in theory, assign it to a new process. You have the assign primary access right. You can impersonate that token. Okay, is that something we can actually do? Well, when it comes to creating process, you need to meet two criteria. You need to either meet the criteria that the process token you're assigning is a child of the current process token. But in the UAC case, that's not going to be the case, because you just grab the random token from somewhere, and it's no longer a parent-child relationship. Or it could be a sibling token. So these are tokens all on the same desktop, but these are effectively keyed off the authentication ID, and the authentication ID between the elevated and the non-elevated session are different. So effectively, this also gets blocked here. So unfortunately, we cannot create a new process with that token. Okay, so what about impersonation? By luck, as luck would have it, the impersonation operation has a completely different behavior to process creation. So even though they potentially give you almost the same functionality, the ability to run code as a different user, the actual sequence of operations for determining whether you can impersonate differs from processes. So the first thing is this token something called an identification token? An identification token is kind of a low privilege token which just allows you to query information. So it says, who is the user associated with this token? You can do that. But crucially, you cannot satisfy an access check with that. You can't open a file while impersonating at this level. So it's fine. If you've got a token which is only identification, you can impersonate it because it isn't a security problem. But of course, in this case, we do not have that. So the process continues. The next one, does the current process have impersonate privilege? And this is one of those special privileges in the token. Again, no, we're a low privilege user. We do not have impersonate privilege, which is sort of a very high level security privilege. Okay, so that's gone. Is the integrity level, this sort of low, medium, high, is the integrity level of the process token greater or equal to the integrity level of the token we're trying to impersonate? Now, remember back to one of the early slides. Your normal token, your low privilege token, is medium, and the admin token is high. So comparatively speaking, the impersonation token you want to impersonate is going to have a higher integrity level. Therefore, that check fails, but in this case, we go to the failure case. And the failure case is we just impersonated identification level. Again, not giving us any security benefit. So, okay, never mind. What can we do about that? Well, it turns out we can change the integrity level. We can't elevate an integrity level because that would be a security problem. But there's nothing stopping us dropping it. But there's a problem. And the problem is we've only got read access to the token. But the token only granted us read access. But we need write access to set the integrity level. Damn. Are we in trouble? Fortunately not. So one of the things you do get as read access is an additional access right called duplicate. And what duplicate allows you to do is create effectively a complete clone of that token object. So all the information, the groups, the privileges, all those are cloned into a new instance of a token object. However, because this is a new object, the access control entry gets rewritten. And we now actually get full control. So we can have write access to that token. We can now drop the integrity level and satisfy that next check. And then finally, the final step of the check is, does the process's user match the impersonating user? Which is yes, because we've got a low privilege user running as, say, Alice, and we have a high privilege user, still Alice, just with more groups and more privileges. So we've satisfied our check. We have now impersonated an administrator token. So what can we actually do with that? Well, one of the common sort of descriptions of bypassing UAC is, I want to get high IL, because that makes me an administrator. But actually, high IL does not make you an administrator. It gives you certain access to certain things which you wouldn't have before. But what makes an administrator is the administrators group, which should be relatively self-evident. And that is not affected by modifying the integrity level. So you can create files in system locations. You can drop files into system 32 if you like. You can create and modify system services, because these are all things which do not rely on integrity levels. In contrast, you can't open higher privileged processes which have higher IL levels, even if they're the same user and same administrator. And you also can't interact with any windows created by that higher IL process due to the way in which the desktop works. You also no longer get access to certain God privileges. So I mentioned that privileges have some bad privileges in terms of like dangerous ones. And basically Microsoft effectively disable, if that current token has an IL lower than high, it disables some of the more dangerous ones. So it disables debug privilege. And debug privilege allows you to circumvent the process security model. It disables load driver privilege. So you can't load drivers as you will. You can write the driver entries because you can write into the registry with an administrator token. But you just can't load the driver afterwards, which just seems kind of silly. So I thought to myself one day, well, it's really inconvenient that the only way I can do this is getting a high privilege application to write to the clipboard. Is there an easier way? Well, it turns out you can open higher privileged processes, but you're very, very limited in what you can access. Specifically, the only things you can do, you can either terminate it, or you can query limited information. So there used to be a query information access right, and in Vista, to support this use case, they added query limited information, which in theory should reduce the levels of information you could access. So I thought, okay, but can you open a process token with limited information query access? If you read the MSDN documentation, the answer is no. Now, MSDN documentation is never known for being incorrect. Like, it's always the oracle of truth for an operating system, except, of course, when it's not. Because if you just try it, it works. And if you actually go and reverse engineer the code, it turns out opening the process token for read access only requires that query limited information access right. So the documentation is completely wrong on this regard, and that it leads you down a sort of false trail of, hey, you're not going to be able to do this, but if you try it, you clearly can. And this works back all the way to Vista. So this is fundamental design decision taken by Microsoft in the development of UAC. So it's something which hasn't just randomly appeared over time. Okay, so as it stands, we can open the process token, we can then impersonate that process token, and we can obviously get admin privileges from that. But where do we get an elevated process from? How do we get that without putting up a prompt? Well, in Windows 7, Microsoft generously changed the default behavior and added the auto-elevation policy. And the auto-elevation policy is the default setting for UAC, and it basically says, if you are a Microsoft binary with a certain manifest which says auto-elevation true, I'm going to allow that process to be elevated without prompting the user. And at that point, all you need to do is, as an attacker, you just elevate one of those auto-elevation applications and you get an elevated process, at which point this whole chain of attack can now proceed. But even if the setting is configured to be high, there's also things like scheduled tasks. And scheduled tasks have a special flag which says, run this process as the elevated user on the desktop. And there's this particular one, the silent cleanup task, is runnable by a normal user and will elevate that task to full privilege. And this, crucially, does not throw up a UAC dialog. So all you do is run the scheduled task, and it will create an elevated process. You can steal its token, and you get UAC bypass that way. So you don't need to worry about modifying the registry or doing any weird behavior with existing applications, which Microsoft could fix. like, this will just give you admin privileges and a UAC bypass without even doing anything, right? So let's quickly demo that. Because I'm on a very limited laptop, unfortunately, I do not have a VM of this, so I've got some videos just to demonstrate it. Okay, so in this particular case, we're on Windows 7. We try and write a file into, say, the Windows folder, which is an admin-only location. I can then run a auto-elevating application, such as MMC, and we should now be able to see that we get this high privilege process, which we can access the token of from a normal user. And that has admin groups and all that good stuff. We then run my bypass UAC tool, which is going to do this entire attack. So it finds the elevated process and then just impersonates it and just drops test.txt into the Windows folder. And there we see, hey, it's now appeared. We can print it out, obviously, hello world, because why not? And we can actually now see, if we look at processes which are impersonating, we should see like there's a bypass UAC executable, and it is impersonating. In that particular case, it is a medium IL token, but it is an administrator token. So we got full privileges. And just to double check, we can look at the process token, we see it's a limited token, and that does not have admin privileges. So we're now impersonating admin as a normal user. So that works great up until Windows 8.1. Unfortunately, in Windows 10, either due to my disclosures or just through some other modifications, Microsoft changed the behavior of impersonation. Specifically, they added 2 extra steps in the impersonation check. The capability check I'll go into a bit later, but the other one, the elevation check, is kind of important to this attack. So what the elevation check does is it basically checks for mismatches in elevation. It basically says, okay, are you trying to impersonate an elevated token? If yes, I'm only going to allow that if you are already elevated, so your process is already elevated, or you do not have a special flag. And this flag basically says, I'm running in the limited UAC session. So unless you have that flag set, this will fail and will drop you straight to identification only. Okay, so that basically destroys the attack, because the attack relied on the weaknesses in the impersonation check. So you think, okay, what makes a token elevated? What is it about that token which Windows considers it to be an elevated token? Well, the first one is, do you have any of those God privileges in your token? Do you have debug privilege, for example? You probably can't enable it, because if you're running as medium IL, you can't enable the debug privilege, because it's a God privilege. But just the actual presence of that privilege being there is enough to be considered elevated. The other one is, do you have any elevated groups? And the elevated groups are just based entirely on the last relative identifier of the group SID, basically. So in this particular case, we have, say, the built-in administrators group. The last relative identifier is 544, and it goes through a list and goes, right, 544 is an elevated group, therefore your token is elevated. So what this effectively means is we can impersonate that token, but only if we basically remove any admin privileges from it, which kind of makes it pointless, or so you would think. But what you can do, as I say, you can make this token into a low privilege token. You can remove the admin groups. You can remove the privileges. And you can just use a filter token to do that. So that's fine. Now, one thing you can do, without any other funky stuff, is there are privileges in Windows which are maybe pseudo-God privileges. They have, like, elevated access, such as mounting volumes, mounting like an NTFS volume, or creating page files. And while these seem to have an obvious system impact, they are not considered God privileges from the perspective of is elevated. Therefore, you can impersonate a token which has, for all intents and purposes, dangerous privileges. You can even modify the UEFI boot variables, for example. You can impersonate this token even though it's not really an elevated token. So you can still do some fun stuff. But of course, it would be much easier if we could just get admin, right? So one way of doing it is abusing that second part of the check, so checking for this flag. All that flag is saying, if you're in the elevated session, the elevated logon session, you don't have to be an administrator, but as long as you're in that elevated session, we will also let you impersonate an elevated token. So because we can impersonate the low privilege token, while we can't create a process directly, we can use something like WMI, which will take the impersonation token and generate a new process based on that token. At which point we now bounce into that other elevated session, still as a normal user, but crucially now we can pass that check. We can now impersonate that privilege token and get admin privileges again. So let's demo that. So we do the same thing again, right? We see if we can create a file, but this is now on Windows 10 instead of Windows 7. And of course, access denied. That's hardly surprising. But again, we can auto-elevate, so we pop up MMC, and we run my bypass tool again. And so this time, the bypass finds the elevated process, but now it goes, oh, damn, right? I can't impersonate that elevated process, that elevated token. So what can we do? Well, we can restart via WMI. So this is just like demonstrating that we're impersonating effectively the elevated token, but at a low privilege. So we've removed the admin groups, we've removed the privileges from it. Okay? So if we click OK on the window, eventually, God, I'm slow today, it will now respawn, and it runs the same thing again, but now we're in a different authentication session. And it's created the file, and we've now got test.txt, and if we have a look at the impersonation token again, we now find we're actually a full administrative token, and we're elevated, so we've got admin access again. So just by doing this little hop into the other elevation session, we actually gain access to that impersonation token. So that does require an extra step. And it turns out that there's actually a bug or a feature, depending on how you define it, in the LSAS logon user API. And the bug basically means if you impersonate that token, that non-elevated token, but you ask for a new token, which the only thing you're asking for is changing the password, because normally you would have to give username, password, before you're actually allowed to actually log on to a system. But this logon user API has actually ignore what I pass as the username, just change the password so that I can, for example, use it on the network with a different password. And the bug basically is, LSAS looks at your authentication ID and returns you back your elevated token, but with a different password. Now that in itself doesn't sound very helpful. Like, we've already got access to an elevated token, and we can't impersonate it, so surely that doesn't actually give us anything above what we already had. Well, it depends. For example, there's the secondary logon service, and the secondary logon service supports the API's create process with token and create process with logon. And create process with logon, again, would normally require you to pass username and password. But it just so happens it actually has this same flag. It's called something different, but effectively it's the same flag. It just says, take my current token, call logon user, and change the password. At which point, because secondary logon has the ability to create arbitrary processes, that gets you directly an elevated process. So I can very quickly demo that one. So we'll switch up to a bit of PowerShell now. And in this particular case, it captures the elevated token, and then that's literally the exploit, right? You call create process with logon, passing the right flag, and you get a admin privileged process. So we start it up. It's sitting there waiting for an elevated process to appear. So we just start Notepad, for example. We get our admin prompt. It says sort of administrator at the top. And then we can just try and write a file to system32, and if that succeeds, we've got admin privileges. And yep, we don't get access denied, and there we go. It says hello. Very simple. Okay, so up until now, I've talked about the sort of most common UAC case. And the most common UAC case is something called admin approval. Effectively, it is the dialogue which says, do you want to get owned or not? That's basically all it does, right? But there's another type. There's something called over-the-shoulder elevation. And this is, in theory, the more secure one. Because in order to elevate, you need to log on as a different user. So it gives you the sort of same dialogue, but it requires you to put in a username and password. But of course, potentially this is something that a user might want to do, like a power user may go, hey, I'm going to not run as admin approval because that's so trivial to bypass, it's ridiculous. But I will have a separate logon account on my system that I'm going to use for admin elevation. And therefore, I'm secure, the bad guys can't get me, everything's fine, right? And for the most part, it is fine for some definition of fine, right? One of the main differences is because they're two separate users, that inherent sharing now gets split. So things like the user profile. The admin processes run with a different on-disk profile to the non-admin users. The registry hive is different. But, and this is kind of important, kernel object sharing is exactly the same. So both your low privilege tokens and your high privilege tokens both have that same logon SID. And both tokens both have the same logon SID in their access control entries. So we can still steal a token from an over-the-shoulder elevated process. So what can we do? Well, we can't impersonate, that's for certain, right? If you remember the process, it checks the IL, and then it checks whether the process's user matches the user you're trying to impersonate. And if they do not match, then I'm going to immediately fail. You get identification token, and that is the end of your privilege escalation route. And this, on the face of it, would sound like it's job done, right? We are now secure. We can't create a process with this token. We can't impersonate this token. Therefore, utterly useless. That wasn't until Windows 10 came along. And for other purposes, I think this might be related to containers, silos, whatever they want to call them this week. Microsoft added a new check in the impersonation security check, specifically this capability check. And if you can pass this, it occurs before the user check is done. If you can pass it, automatically allowed to impersonate that token. So that is interesting. If we can do this, maybe we can abuse this for privilege escalation. And what this is, the capability check is related to something called low-box tokens, which is a new token type Microsoft introduced in Windows 8 for app containers, the universal Windows applications or Edge's sandbox. These are all low-box tokens. So the capability check checks two specific things. First, it checks whether you're running the token in the same session. So when I talk about logon sessions, these are sort of like artifacts of LSASS, whereas the session is effectively your desktop. So are you running these two tokens from the same desktop? Which in this particular case is yes, they are running on the same desktop. So we can pass that check. It then also checks whether both the token in the process doing the impersonation and the token you're trying to impersonate are low-box tokens. Basically, are these two tokens sandboxed? And we can influence this. We can call the API nt create lowbox token, which gives us arbitrary lowbox tokens with full control. As long as we're a normal user. We can't do this in a sandbox because that would be dangerous, but we can do it because we're just a normal user, right? It then goes to say, okay, does the process token, have a special capability? And these capabilities are something you can specify in nt create lowbox token. They're just a list of SIDs which define certain capabilities on the operating system as reflected in the app container model. So app container uses a capability model. You say, I want to access someone's documents folder. Now, unless you're granted the user documents folder capability, you cannot access the user's documents, at least in theory. But we can just add this special capability for impersonation as much as we like. We're running as a normal user, right? Like, the security boundary here is a sandbox token gaining this capability, which shouldn't be possible. Instead, we're a normal user, so we can assign this whatever we like. And then basically, the only other check is, are these two sandbox tokens in the same app container package? Which, again, is something we can control. So we can pass this entire check. The only problem is we end up with impersonating the admin in a sandbox. So we still can't write to admin stuff, right? We can't modify System32 because we're in a sandbox. The whole point of the sandbox is to stop us doing that, right? So I was thinking, okay, how can I bypass this? Well, there's going to be times where the user identity is kind of more important than whether you're sandboxed or not. And one case of this is a special capability called the enterprise authentication capability. And the enterprise authentication capability, which again, we can just set in create lowbox token, grants that user access to their credentials. Not their password directly, but things like their NTLM authentication or their Kerberos authentication. So even though you're sandboxed, you can get access to their Kerberos authentication. Which, if this elevated user is a domain user, you've effectively granted that other user access to their networking resources. So if they're a domain admin, for example, you've basically compromised the domain at that point. So we can do that. So let's just demo that. So in this particular case, I've set up a domain, so I need multiple machines. I have on the domain controller just a simple website which does NTLM auth. So in this particular case, we can see just briefly that it's logged on as user 1. And user 1 is our limited user. And then we go back to PowerShell again, and we can actually create an app container process with this special impersonation capability, and then we'll run a really dummy, stupid application, which the only thing it does is tries to do a web authentication request to the web server. We then set the impersonation token, so we can do this because we can impersonate that other user because we've got this impersonation capability. So let's just run up a copy of Notepad. In this case, we need to log in. We need to use our domain admin credentials, because why not? And so we've got now a privileged copy of Notepad just sitting on your desktop. But if we run the PowerShell script, it finds that and will run that web test program while impersonating the admin, our domain admin. And as we can see, we now get authentication as admin instead of as the user 1. And therefore, we would have compromised their system. So that's wonderful and all. But, of course, not everyone is on the domain. And not everyone is stupid enough to use their domain admin credentials to elevate themselves to a privileged position. So actually, even in the domain environment, it's possibly less likely. Maybe if you get on a actual admin's workstation, they think they're clever. They're using a normal domain account, which has no privileges, and then using their domain administrator account to elevate themselves to admin, to local admin on that box. So I thought, okay, I need some way of getting privilege escalation on an isolated system, no domain involved, just all local administrators. Can that be done? And I'm not going to tell you the service I'm abusing to do this, because all you need to do is find the right service, right? But I will demo that in real time. So no more of this video crap, right? We'll actually go for a proper live demo and pray to the demo gods that it works. So again, I've got a PowerShell script which will do some funky stuff. So first, I run it with PowerShell, and it's going to sit there and going, hey, give me an elevated process. Give me an elevated process, please. Then if we just say start Process Explorer, and as you can see, well, in this particular case, we're logging in as a local administrator, so not a domain administrator. So effectively, the credentials are probably less important. Okay, oops. Right. And we get a pop. Like, Process Explorer didn't even start, right? Because we had the please accept the EULA. Ah, okay, fine, fuck you. So who am I? Oh, well, I'm system, okay? So even though we had, even though we now logged in as a completely separate user, like, we've abused that and actually got full admin privileges through over-the-shoulder elevation using basically a variant of the trick I just demonstrated. So, you may be asking, is there anything safe you can do on Windows? Not just in generally, like from a security perspective, of course. About the closest you can come to safety, if you need to use admin and non-admin accounts on the same machine, is to basically use the switch user, the fast user switching capability. And do not use the Explorer. Oh, do not use Explorer to do this. Explorer has like a little image of your user account, and you can click on that and click switch user. Explorer is running as that normal user. So an attacker could potentially inject into Explorer and hook these functions, and then display a fake login prompt and basically say, hey, I've captured your credentials, right? So as long as you hit Control-Alt-Delete, the secure attention sequence, in theory, arbitrary code on the machine can't intercept that unless there are administrators already, and you can from there switch users. And that's about the only way you can do it securely on Windows. So yeah, admin approval UAC, as everyone probably guessed, is completely broken. And it's not entirely clear if Microsoft are going to fix this, because this is still working in RS3, so this is the 4 creators update. They're obviously rolling out RS4, the insider builds for that. Who knows whether it's going to get fixed in the meantime. And even because of actually changes in behavior of Windows, which weren't obviously security issues, you can still then bypass over-the-shoulder UAC using the default behavior in Windows 10. So yes, if you have to use Windows securely, I would recommend fast user switching, but don't hold me to that because that probably has other problems, right? But that is the end of my talk, and I'm thankful that you obviously sat here and listened to me talking about this, and hopefully you've got some interesting ideas. Certainly from a red teaming perspective, it's incredible that you can still find people on enterprise systems with admin approval UAC. It's kind of ridiculous. But other than that, I'm willing to answer any questions people have now, or obviously I can meet you outside if you prefer. But thank you very much, and have a good rest of the evening. Thank you. So I can't see anyone asking questions, which is always a good sign. So thanks very much. Oh, there is apparently one. Yeah. Just wait for the mic.
Hello. Do you have the source code of your samples published somewhere?
Yeah, so yeah, I forgot to mention that. I will publish the bypass UAC, that's that executable, and these PowerShell scripts. I'll publish those on my GitHub page, but you probably want to, if you follow me on Twitter, I'll post it on there when I manage to publish it, which probably won't be now until I get back from Russia next week, but I will do. They will become available.
Okay, and what's the address?
It will be github.com/ see if I can actually, it's probably easier to show my, oops, that's wrong. Sorry, show's over. If you just follow the Twitter account, which is @TIRANIDDO, a bit of a mouthful. Like I've got like like one of my top hits is like sort of my GitHub page and stuff like that, so you can get it from there. But I'll tweet it out from there next week sometime. If that's okay.
Okay, thank you.
Thank you. Okay. Thank you.